All right, so we this week are going to be covering inductive reasoning. Chapter before, we were working on deductive reasoning. And recall that deductive reasoning was creating an argument using a formula, hence syllogisms. And I'm sure you loved syllogisms. To be honest, I love syllogisms. I don't know why I love them. But whatever. Anyway, so for me, I enjoyed the idea of creating a formula in which it was helping me have a true argument, right? So if you have your two premises that are true, premisi, it is what it is. Anyway, two true premises creates a true conclusion. Anywho, so we have three parts to the syllogism, two premises, the major, the minor, and then we have the third part, which is the conclusion. Okay. Recall that we had modus ponens, modus tollens, chain argument, disjunctive syllogism, and argument by elimination. And chain argument. I think I forgot that one. And then don't forget the entomemes. We're talking about key parts or parts that were implied. Remember the two premises. Only one of them was implied but not stated, which gave us our conclusion. So oftentimes one of the premises was missing, which unfortunately leads oftentimes to misunderstandings or assumptions. We already talked about assumptions. Okay, inductive reasoning. This is where we talk about evidence and statistical data. Yeah. Okay. I actually really like inductive reasoning for the fact that I got information that's going to bag on my main point. Ooh, you just reminded me of something. I'm going to come back to that. Okay. So, anywho, when we talk about inductive reasoning, it differs from deductive reasoning in the fact that it allows you to think critically. What do you know? We're in a critical thinking class. Ta-da! With inductive reasoning, you are using evidence for credibility before drawing generalizations. So, with inductive reasoning, you have the information in front of you to pull up your point. You're not making a hasty generalization. You're actually using data that's going to give you information so that you can come up with your actual generalization. So, inductive reasoning occurs when we use facts or research findings to make said generalizations. So, the example I'm going to use can also be used as a fallacy if it is used incorrectly. Okay, so used incorrectly is based on assumptions, not data. So if you were to use the following statement using assumptions or hasty generalizations, that's when it becomes a fallacy. But when you use the following statement using actual research data and true information, then you have a true statement. So most A's are B's. We have received data that most A's are B's. Because we received that information, I can say that if I encounter an A, it's probably also a B. However, there are exceptions, and exceptions are always the case. There will always be exceptions. But when we get data that most of a thing can be also this, then we can assume it to also be true. If we see an A, it's most likely a B. Okay, again, I know that is very general. And when it becomes a fallacy is to assume all A's are B's. That's the difference. When you assume all A's are B's and you encounter an A and assume it's a B, that's when you're like, okay, that's a hasty generalization and also a stereotype. Okay. When you say most A's are B's, you could say most teachers are highly credited and have a lot of experience. Most A's are B's. Most instructors are highly credible, educated people. I'm just going to use that as an example. So if you encounter a teacher, they're most likely going to be a highly educated, well experienced person who's giving you information. However, there are exceptions. Not all A's are B's. There are exceptions. So that's how you can say in inductive reasoning, some can be, but not all. If you were to say all instructors are highly educated, then that's a fallacy because not all A's are B's. Okay, so that's how you know inductive reasoning is when you're actually using the research and the data to back up your point, but also recognizing there's always an exception. There is always an exception. And I'm going to try and draw this for you to give you an example. Can you see those? Do those two lines intersect? No, they don't. But if you were to add more information and more data, at some point they're going to. While we don't see it yet, based on the information, if the more and more data we get, we can infer that actually those lines do intersect. So it's all about the information. So we're going to keep going. And I know that was a junky looking chart. I've got a thing behind me. I can't use a chalkboard. Anyway, chalkboard. How old am I? Whiteboard. Okay. How do we learn inductive reasoning? Trial and error. Trial and error. We might not know how to do a thing, but if we do it enough and screw up enough and find the right way to do it, ta-da, right? It's trial and error. What works? What isn't working, right? That's the data. That's the information you're getting. Kids, often people do dumb stuff, and that's how you learn, right? You could be told 100 times, don't put your hand on the hot stove, it's going to burn you. What are you going to do? Oh, well, let me see. It's kind of like you go to a restaurant and the waitress is like, don't touch the plate, it's hot. What's the first thing you do? Touch the plate, it's hot. Okay. That's how we learn sometimes. Again, trial and error. Trial and error could also be, and I don't even like this as an example, but I use this from my mentor. Do you marry the first person you meet? Or the first person you date? Maybe, right? Or maybe you need a little trial and error. It says the person has been married and divorced a couple times. A little bit of trial, a little bit of error. Right? But I'm learning, right? We'll see. This is a lot of inductive reasoning that I'm doing in my love life, right? Do you marry the first person I date? I am so glad I did not, right? So that was my trial and error. There are some people who, for them, it worked perfectly, right? Not all A's or B's, okay? So some might, some don't. There's always an exception. And I didn't get straight A's until college because I didn't know how to do school, right? Trial and error. I maybe got some A's and the class I could fart around the most in. That's what I did best. But when I got into college, I was like, oh, this is real. And that's when I got all the straight A's because for me, it was trial and error. I was learning how to do school. Okay. Inductive reasoning. Evidence is not 100%. It is not 100%. While I have some evidence, the more evidence I get, the more I know. Look, they intersected right there. Work with me here. Okay. Evidence is not 100%, but it's more probable the more amount of evidence that gets increased. So the more evidence you get, the more answers you get. We'll talk about random sampling in a second because at some point it all levels out because you keep getting the same information. But the more evidence that you get, the higher your chances are that you are as close as you can possibly get to being correct. Okay, there's always the outliers. Something always happens here or there, but okay. So here when I talk about point of intersection, that's what these lines are. I'm going to scratchy poo them in just a little bit. In fact, I'm going to give you a video in just a second that's going to do better than what I'm doing. Okay, but okay, here's my line. I like them better this way. Okay, point of intersection. At what point do these intersect? Right now, with the evidence we have, these lines do not intersect. Like my evidence says, no, the lines don't intersect. So if I were to give my research, I'd go, nope, based on the data, that's not the case. But the more research I do, the more data I get, the more I'm going to see that these two lines at some point will intersect. Okay. Honestly, oftentimes you can infer based on the trajectory of the points where they're going to line up and where they're going to hit. So you could say based on the trajectory of the data that we have, we could say that they intersect. But based on what I have right now, they do not. Okay. So showing how the original evidence was inaccurate based on more evidence. Okay. The more evidence we get, the more we can say, hey, look, this is what we're seeing. Okay. Also look for the most evidence, the quantity of a sample to make your best judgment. Okay. So I'm going to give you a quick video and then I'm going to be right back. And this should help give you a little bit more information or maybe potentially confuse you. I don't really know, but we'll come back to it. The idea here is that evidence needs support. I'm sorry. Yeah, evidence needs more evidence for its support.